All right, let's dive in, folks. Today, we're going to be looking at this paper called PhD Knowledge Not Required, a reasoning challenge for large language models. I'm already kind of hooked by the title. It sounds like they're taking a jab at all these super specialized benchmarks we use in AI these days.
Yeah, it's a fair point, I think.
Yeah.
The authors are arguing that benchmarks like GPQA and HLE, they're useful in some ways, but they're so focused on specialized knowledge that it makes it hard to really understand how well a model can actually reason. It's like, trying to judge someone's problem-solving skills by testing their knowledge of quantum physics. Like, it's not exactly a fair comparison, is it?
Right. Not all of us have a PhD in physics.
Yeah.
So how are they suggesting we change things up? What kind of reasoning challenge are they proposing?
Well, they've turned to something a little more relatable, and I'd even say fun.
Okay.
The NPR Sunday Puzzle Challenge.
Oh, yeah.
You know those word puzzles that make you go, oh, that's clever, when you hear the solution?
Absolutely. I love those. They're definitely challenging. But the answers are usually pretty clear. Seems like a good fit for testing how well AI can reason.
Exactly. And get this, the authors actually went through 13 years worth of these puzzles to create a data set.
Wow.
They filtered out any puzzles that had multiple answers or vague answers, and they made sure to include all the necessary context. So the models have everything they need to really reason effectively. They basically became expert puzzle editors themselves.
Very dedicated.
Yeah.
Okay, so they've got their benchmark. What LMMs did they test out on these puzzles?
Well, they tested a bunch of the latest reasoning models, OpenAI's o1, a few versions of o3 and o1 Google's Gemini 2.0 with flash thinking DeepSeek's R1.
Yeah.
They also included some non-reasoning models like GPT-4o and Claude Sonnet 3.5 just as a baseline.
Interesting. So who came out on top in this battle of the NPR puzzle solvers?
OpenAI's o1 took first place with a 59% accuracy rate.
That's pretty impressive.
Yeah, and this suggests that o1 might have a really strong foundation of general knowledge compared to models that might do well on those very specialized benchmarks.
That's interesting. I'm sure it wasn't all smooth sailing, though.
Right.
Were there any surprises, any unexpected findings?
Absolutely. One of the most interesting things was that DeepSeek's R1 had this weird tendency to give up.
Wait, hold on. An AI admitting defeat? That's a new one. What happened there?
Well, they noticed two different kinds of giving up. Sometimes R1 would just offer an answer that was totally out of the blue, like it had no connection to any of its previous reasoning. It's like it hit a wall and just threw its hands up.
Kind of like a student trying to bluff their way through an exam.
Yeah. And then other times, R1 would actually admit that it couldn't find an answer that followed all the rules of the puzzle.
Okay.
And then it would go ahead and give an answer that clearly broke the rules.
No way. I need an example.
Okay, so in one puzzle, it was asked to find a word with an I in each syllable, but no I sound. And R1's answer. Queuing. It even tried to argue that some pronunciations might work.
That's amazing. It's like it was trying to outsmart the puzzle itself. So clearly R1 needs a bit more work on its reasoning skills. But seriously, what do you think this giving up behavior tells us about these models?
It's a really good question. And it suggests that we still have a lot to learn about how these models approach problems. It could be a limitation in the training data or maybe even the model architecture itself.
That makes sense. It's not enough to just make these models bigger, right? We need to make sure they can deal with ambiguity and actually work through tough problems.
Exactly.
So were there any other challenges or limitations that came up with these models?
Yeah, so they also found that R1 would sometimes get stuck in a kind of reasoning loop. It would just keep going and going without reaching an answer. And it would hit that output token limit without ever producing a final answer.
Oh, that pesky token limit. Always getting in the way of creative thinking. But it does bring up another important point, right? It's not just about AI thinking more. It's about thinking smarter and more efficiently.
Exactly. And speaking of efficiency, the paper also digs into this idea of how much reasoning is enough.
Okay.
They actually analyze the reasoning outputs of R1 and Gemini thinking to see how the accuracy changed depending on how long the reasoning process was.
Wow, so they could actually track the model's thought process and see if more steps led to better results. What'd they find? Was there like a point where thinking more didn't really help?
Yeah, that's exactly what they're looking for. And their analysis showed that for these models on this benchmark, at least reasoning beyond 10,000 tokens, didn't really improve the accuracy much.
So even in the AI world, there's a sweet spot for problem solving. It's not always about brute forcing your way to the answer.
Exactly. And knowing where that sweet spot is can be really helpful, for making these models more efficient and better, especially when you consider how much time and computing power it takes to run them.
All right, that's a lot to take in already. I'm really interested to hear more about what all this means, though. Like, what are the big takeaways? How does this paper change the way we think about AI reasoning?
Well, it's a strong argument for moving beyond those super specialized benchmarks. If we only test models in those really narrow domains, we might be missing out on a whole bunch of their capabilities and potential limitations.
Right. It's like judging a fish by its ability to climb a tree. We need a more well-rounded view of AI reasoning. And this whole giving up thing, the token, limits the question of how much reasoning is enough. It all points to the fact that we need to better understand how these models actually work, right?
Absolutely. We need to move beyond just creating models that can beat humans at specific tasks. It's about understanding how they think, how they learn, and how we can make them more robust and reliable in a wider range of situations.
I'm with you there.
Huh.
But before we get too philosophical, let's dive into some more of the specific findings from this paper. What other interesting things did they discover about how these LMs reason?
One really interesting thing they looked at was how confident the models were in their reasoning. They found that both R1 and Gemini thinking, even though they're pretty advanced, sometimes showed a surprising lack of confidence.
Oh, really? It's kind of funny to think of like a super intelligent AI being unsure of itself. How did that show up in their performance?
So they noticed these models doing things like backtracking on answers they'd already given, repeating themselves, and giving explanations that were full of uncertainty.
So even though they can do some complex reasoning, they still struggle with that feeling of, am I on the right track? It's almost like they're second-guessing themselves even when they found the right answer.
Exactly. And the paper actually points out a really interesting example where R1 figures out the correct answer early on, but then it goes off on this tangent and starts exploring other options for no clear reason.
So it's like it found the solution but didn't trust its own judgment. I wonder if that has something to do with how these models are trained. Maybe they're being penalized for making quick decisions or not considering all the possibilities.
Yeah, that's a good point. The training process might accidentally encourage them to be more cautious or even hesitant, especially when they're dealing with problems that need a bit of creativity or out-of-the-box thinking.
Makes sense.
Yeah.
It's like they're overthinking things, which is something we humans definitely do too. But how did the researchers actually measure this lack of confidence? Was it just like a general observation, or did they actually quantify it somehow?
They really dug into the reasoning outputs. Looking at the language and structure of the responses, looking for patterns of hesitation, contradictions, and expressions of uncertainty. It wasn't just about whether they got the right answer, but how they got there and how sure they sounded along the way.
So they weren't just looking at whether the model passed or failed the puzzle. They were looking at the whole thought process. I'm starting to see why they chose the NPR Sunday Puzzle Challenge for this. It's not just about finding the answer, it's about understanding the journey of getting there.
Exactly. And focusing on the reasoning process instead of just the outcome gives us some really valuable insights into how these models work. It's like we're peeking inside the black box and getting a better understanding of how they handle complex problems, uncertainties, and even their own limitations.
It is really fascinating to see how this research is showing us both the strengths and the weaknesses of these cutting-edge AI systems. We're not just talking about cold calculating machines anymore. We're seeing glimpses of something that looks more like human thought, with moments of brilliance, hesitation, and even a bit of humor.
It really does make us rethink what artificial intelligence is and what it can do. And by understanding these more nuanced aspects of AI reasoning, this paper is helping us develop systems that are not only intelligent, but also more transparent, trustworthy, and ultimately more beneficial to humanity.
Right, we've covered a lot of ground here, from specialized benchmarks and NPR puzzles to AI giving up and a lack of confidence in some models. What are your final thoughts on this research? Where do we go from here?
I think this paper really opens up a whole new way of thinking about how we test and evaluate AI reasoning. It's like a call to action for researchers to move away from those really narrow and specialized benchmarks and start using more creative and relatable approaches. Like, why not use something like the NPR Sunday Puzzle Challenge? It taps into general knowledge and problem-solving skills, and it lets us see these models from a different angle. It reveals strengths and weaknesses that we might not have seen otherwise.
Yeah, I totally agree. It's like we've been so focused on teaching AI to pass these standardized tests that we've forgotten to teach it how to think outside the box, how to be curious, how to deal with uncertainty. This paper is a good reminder that real intelligence is about more than just memorizing facts and having specialized knowledge. It's about being adaptable and creative, and having that spark of insight that makes us human.
Well said. And even though those findings about models giving up or not being confident might seem like bad news, they're actually super valuable insights. They show us where we need to focus our efforts. We need to develop new training methods and architectures that encourage persistence, strategic exploration, and a healthy dose of self-belief.
Yeah, it's like we're raising a whole new generation of AI thinkers. And we got to give them the right tools and mindset to succeed in a world that's full of complex problems. It's not just about solving puzzles. It's about preparing them to tackle the big challenges facing humanity. Things like climate change, disease, poverty, you name it.
Exactly, and that's what makes this research so exciting. It's pushing us to think bigger, to dream bigger, to imagine a future where AI isn't just some tool for automation, but a partner in problem solving, a collaborator in pushing the boundaries of human knowledge.
It's like we're on the edge of a whole new era of AI, one that's less about copying human intelligence and more about amplifying it, augmenting it, and maybe even inspiring it in ways we can't even imagine yet.
It's a really exciting prospect, and I can't wait to see where this all leads. Who knows, maybe someday we'll have AI systems that can not only solve the NPR Sunday Puzzle Challenge, but also come up with their own puzzles to challenge us.
That would be something. But on that note, we'd love to hear your thoughts. What are your takeaways from this deep dive? What questions does it raise for you about the future of AI reasoning? Leave us a comment below and let's keep this conversation going. Until next time, keep those minds sharp and happy puzzling.